And we are live.
Hello, everyone, and welcome to Consul Community Office Hours. We've got this esteemed team with us today. We've had a few of them on before, but I'm really excited for this one because we are going to answer one of the most frequently asked questions that I have seen across forums, general response on social media, and even on this chat as well, which it's been a long-awaited question. Today, we're talking all about Vault and Consul. We are not going to talk necessarily about Vault. We have Vault Community Office Hours for that, but we are going to focus specifically on using Vault with Consul. There would be Vault as a CA for Consul, and there's going to be some stuff about autoconfig. I have the esteemed Consul education team on camera today with us. If you have any questions, you are welcome to interact with it in chat. We welcome those questions. I will ask them live. Please do drop them in there. As you do, however, keep in mind our community code of conduct. Make sure to be welcoming and professional. With that, why don't we do some introductions? Daniele, why don't you start with introductions, and then we'll go to Eddie, and then we'll go to Karl.
Yes. Hi, everybody. I'm Daniele. I live in the Netherlands, and I'm a member of the Consul education team. I've been with HashiCorp for 3 years now.
Hey guys, my name is Eddie Rowe. I'm in San Marcos, Texas, just south of Austin. I've been on the Consul education team for about a year now, and I write learn guides, one of them being autoconfig, which we'll discuss later.
And hello, everyone. I'm Karl. I'm one of the product managers on the education team, and I'm fortunate enough to have Daniele and Eddie be on my team.
Yay, and I'm hiding. I'm Lynn, and I'm hiding as in I'm pretending today to be part of the Consul education team. I'm just part of the education team. I work on the Vault product, so I'm here to just be that additional voice in the event we need to get into some of the details of Vault here today.
Yes, we appreciate Lynn being here. Very, very important because not all of us are Vault experts. So if there are Vault questions that come through the chat, at least we have some coverage. So feel free to ask them. With that, we're going to get started with the Vault as a Consul Connect Service Mesh Certificate Authority. That's Daniele. And then we'll talk about autoconfig with Eddie. So Daniele, get started.
I'll kick it out. Let me share my screen. Okay, I hope everybody can see my screen.
Yep, we can see it.
Perfect. So, and the screen just presents, we recently released a tutorial on how to configure Vault as Consul Connect Service Mesh Certification Authority. And today we are going to demonstrate how to change the configuration of an existing Consul data center to move from embedded CA to Vault as Connect CA. So before starting, I already started an environment. Let me just set up all my variables so that we're sure that we can use it. And let's see what's going on in the environment. So we can see that we have 3 servers and 2 clients. Each one of them has 1 service deployed. We can see the service deployed. But also we're going to check on the Consul UI and Vault UI what's going on. So in Consul you can see that we have 3 services, 1 Consul with 3 instances, and API and web both part of the service mesh. And we have Vault. Let's copy the token. And we can see that we already have 2 secret engines enabled, PKI and PKI intermediate, because we are already using Vault as for creating TLS certificates for Consul security. So let's check what's the current configuration for Consul Connect. To do so, you can use either the CLI, the Consul CLI, or the API to verify the Connect certificate authority configuration. So we will see both commands. And you can see that at the moment we have Consul as provider and the configuration is tuned to be like as short as possible. Ideally, if we had 1 hour for demonstrating this, we could see live rotation. I don't think we will have time to see the rotation, but consider those are the lower possible values for certificate rotation. So your certificates will be lasting 1 hour in this scenario. As mentioned, you can retrieve exactly the same thing using the API, using the ConnectCA configuration endpoint. And as you can see, the output is the same. So we are eating the same information. On the same thing, we can check the certificates for the root CA using agent connect CA roots. And we can see that the certification authority is Consul, and we can examine the root certificate. When you are debugging Connect, the service mesh for Consul, remember that this endpoint is always available. You will not need a token or any extra special permission to retrieve this, because this is going to be needed for you to get the certificates or to connect to the clients and endpoints. And if we want to do one extra step, we can actually see what's inside, what are the information in the root certificate using JQ and OpenSSL. And we can see that the common name of the issuer is Consul related. And when using Consul as Connect certification authority, every certificate will have a different serial number. Things will change, and we will see that when Vault is used. The same thing we mentioned, we had two services running in the service mesh, so that we can check the certificates for the service mesh. Sorry, for the service. So let's start with the web. So here we are hitting the agent connect CA leaf, and using the service name, we can check the certificate. And we see that even here we have a serial number that is incremental, and we have the certificate, and in this case also the private key. Keep in mind that at this time I have exposed as a environment variable a Consul valid token that enables me to access this. Otherwise, you will not be able to access these endpoints with the anonymous token or without passing a token. The same, we can check the content of the certificate using, again, JQ and OpenSSL. And we can see that the issuer is the same as the certificate we examined before, but this time the CN is related to the service name and is a service and is created and managed by Consul. Again, in this case, the serial number is exposed here as well and is incremental. What's next? So at this time, everything is working. The services are talking with each other inside the service mesh, but we want to introduce Vault at this time. So first of it all, we have to write a configuration that will tell Consul to use Vault as Connect CA. Previously, we configured the CA inside the configuration file, but once the data center is started, it's not possible to change that configuration unless using specific API endpoints or using the CLI. So first of it all, we'll have to write a new configuration file that will contain the configuration for Vault as Connect CA. So let's open a file. I'm using Vim, but you can use any editor you have available in your machine, and let's use an example configuration. So you can see that the provider indeed now is Vault, is not Consul anymore. For the configuration, we are using the Vault address. We have to specify a token. This one is a placeholder. We are going to replace it in a second with a valid token. Important things to notice are the root PKI path and intermediate PKI path. Vault provides you with secret engines called PKI to generate certificates. In this case, Connect makes no exception. It's going to use two different PKI paths, one for the root CA, one for the intermediate CA. If these PKI engines are not already enabled in Vault, Consul, when changing the configuration, is going to create them and use them. Otherwise, if they already exist and we have a token with the right permissions, Consul can actually leverage the already existing PKI paths and use them to generate certificates. Ideally, we suggest you to use a new one. You don't want to overlap PKIs for multiple uses. Okay, let's take the right Vault token. Let me figure what's the, okay, so this is the Vault token. Let's go back here. Okay, let's save. And now we can use the API endpoint to configure the CA. So the endpoint uses Connect CA configuration, and using the put kind of request, we are going to update the configuration. And you can notice that we're passing as data the configuration file we just created. Okay, so apparently Consul doesn't give you much information on this, but we can just go and check that the configuration got changed. So let's verify this with the CLI. And as you can see, the provider is now Vault, and the rest of the configuration reflects what we just passed by the configuration file. When the configuration gets changed and we move from a certificate authority to another, Consul will automatically update certificates for services. And in case we already have certificates, like in this case, it will cross-sign the old certificates so that no service gets cut off the communication. We can go and verify now that so we verified before that the service had a specific certificate and a configuration, the service web. We can go and check if that got updated. Okay, so from the output, it looks like nothing changed. We see that we still have the serial number, that the certificate seems the same. Why this? This is because Consul provides you a caching system that for these certificates doesn't expire in reasonable time. So sometimes you might think while doing these operations that the certificates are not rotating. So let's first move to verify that the certificates for web are, for API are respecting now the Vault certification authority, and then we're going to see how to invalidate the cache and actually verify the new web certificate. So as you can see here now that the request is hitting API as a service using the same endpoint basically. And here we can see the difference. So we can see that now the serial number is not an incremental number anymore, is hash generated by Vault, we can see that now the certificates, there is more than one certificate because of what I mentioned before, that Consul is now cross-signing all certificates so that all services can still communicate and no communication is cut off because of expired certificates. And well, we get the SPIF URL for the certificates. I mentioned that for web, if we go back to web, we still see the old certificate because of the cache. One way to trick this cache mechanism is to change endpoint that we use to query Consul. So let's change the Consul HTTP address that we use to a different server. And after that, if we hit again the same endpoint web, we can see that now we get the proper result. So if you are like undergoing this operation and it seems that that certificates do not change, or if you are hitting rotation time and it seems that certificates are not rotated, remember that this might be because of the cache. So this is an easy way to invalidate the cache and verify that certificates are being rotated. Last thing, let's go back and check Vault UI. Let's refresh the secret engine page. Oops, we need a token. I have it somewhere, yes. Now we can see that alongside the old PKI and PKI intermediate that we had before for signing TLS certificates, now we also have connect root and connect intermediate. There were the PKI paths that we configured as connect service mesh CA paths. That's it. Nothing else.
How convenient. That's super cool that it makes those in there automatically like that.
Sorry, repeat.
Oh, I was just saying it's great that those showed up. It's amazing, like all the configuring. Normally I'm like, oh, then you do it at Vault, then you Vault this tutorial, and
yes. And so basically those are like all the steps. From this moment on, all the new certificates for new services are going to be using Vault as Connect CI. We can try. I'm not sure if this is going to work, but we can try it anyway. To spin up a new service and verify that the certificate gets signed by Vault. Okay, ideally we registered a new service called UI, and let's see the certificates for it. So we are going to use the same endpoint. This time, instead of web, we're going to use UI. And you can see that the certificates get generated by Vault again. And you can, usually an easy way to verify that is checking the serial number, because if we're using Consul as Connect CA, you're going to use like a very small incremental serial number, but you can also like unpack the certificates and verify the content yourself using OpenSSL.
Yeah, we actually have an interesting question in the chat.
Yes.
So for those who are not as familiar with Consul, does this mean that HTTPS would be enabled between services through the service mesh? So does that mean that you are enabling HTTPS by adding Vault as a PKI, or does it mean that HTTPS was always enabled in the service mesh? It was just a matter of which certificate you were using. Okay, so it's actually the latter. So if you are if you have Consul Connect service mesh enabled, that already means that all the connection between services in the mesh are already encrypted using mTLS, so that there are going to be certificates on both ends. In what we are doing in this scenario, we're just deciding, we're just configuring which certification authority is going to be used
to sign those certificates. The beauty or the advantage of using Vault is that you get a centralized point for configuring that. You get a more tunable engine to define like what are the TTLs or like the life of those certificates.
Thank you. And you were actually you answered my second question already, which is why would you use a separate certificate authority? But you already answered it, so that's good. One of the other questions that I had is that there have been a lot of questions about how to use Vault as a CA for Consul service mesh specifically. What challenges did you encounter as you were working through the tutorial and as you were building the instructions for it?
So the main one I already showed it during the demo. That was at some point it didn't seem that certificates were rotating, and that is because we figured that there is like this endless cache on the Consul side that basically once you hit one of the endpoints for web or for API for a service, basically that endpoint keeps returning the same value over and over, and we sort of work that around by changing the Consul server that we're hitting, and the other one was like to find the right tuning on the CA. But so let me yes. Specifically, like we figured that it might be necessary. Consul might want you to specify the key type and the size of the key. RSA is not the only option. There is elliptic curve as another option, but without specifying it, in some cases Consul might get errors. So in the tutorial, we provide both the option to define this specific configuration.
That is good to know. That is important to know too, especially if you want to use a different key type.
Yes.
We have another question. Is it recommended to use Vault with Consul? Is it recommended to use an external Vault, something like a managed service, or an internal Vault instance? So I'm assuming that's something that you manage. And to extend that question, does it make sense to use can you just use your existing Vault instance? Daniele, I know you mentioned you probably want to create new secrets paths, right, for Consul specifically.
Well, so the idea is if you already have Vault in your network and it's already being used by other systems, I see no issue in using that instance also for ConnectCA. Exactly, the main like attention point would be exactly that. You want to use original PKI paths because the outcomes might be unpredictable if you reuse the same PKI paths for like multiple reasons. But apart from that, secret engines in Vault are sandboxes. That they're isolated. So as long as performance permits you that, there is no risk issue, no security issue in using the same Vault instance for like multiple purposes or even multiple Consul data centers, as long as you change those paths. And in the tutorial, we also show how to actually create specific Vault permissions to make sure that you only get the right capabilities only to access those paths.
Can I throw one thing in, Rosemary?
Yes, go for it.
That question about which Vault to use, it's a good question, but I think the main thing to remember if you're doing this in a large enterprise setting is that whatever your root CA is signed by, so if you have it on-prem, usually organizations have the root CA signed and intermediates by external trust authority. You would want that also to be placed in Vault, because whatever these application services, they're going to have their certificate sourced by Vault. That also needs to be trusted up the chain. So that's the most important thing, is that whatever has signed your root CA for your organization is also placed in Vault. So that way the applications have that trust chain that lines up with your internal security policies.
Perfect. Thank you. And also thank you all for including the Vault policies. I know that's the bane of everyone's existence, trying to figure out how much, what kind of policies and what least privilege access you need to grant. So we all appreciate that very much so. One of the other questions that I wanted to clarify is that there are a couple of tutorials regarding certificates with Consul and Vault. So there's this one, which is using Vault as a CA for the service mesh, but you can also use Vault to generate certificates to secure Consul. Can you explain some of the differences, and are these the same certificate? Are they separate? How should we think about managing them?
Yes. So historically, even before Consul Connect Service Mesh, Consul configuration in a secure fashion included the generation of certificates to secure communication across agents. This was a different kind of communication than the one in Connect, but it was used for RPC communication across nodes. When we introduce auto encrypt or auto config that Eddie will show in a minute, the amount of certificates needed for the configuration was reduced drastically, and the only certificates needed to be generated at the beginning were the ones for servers. So I can show this in the configuration. I don't remember which files are, but config server. Oh yes. So basically, I created during the startup of the servers one certificate per server, and the clients did not possess a certificate at the beginning, and those certificates were generated on the fly for the clients using the Connect certification authority. So I know that this might be like a bit confusing at the beginning, but the idea is that when you spin up servers, when you spin up a new data center, the servers will need a certificate each in the best case. Ideally, you can reuse certificates, but you don't want that. And then once you generated one certificate per server, all the certificates for the clients will be taken care of by Consul automatically, either using Vault after you have Vault as Connect CA, or using the embedded Connect CA. But the nice part is that you will not have to generate a new certificate every time you want to spin up a new agent and register a new service.
Awesome. Yes. So thank you for that explanation. I know some folks do get a little bit confused. These are two separate certificates, and they should be two separate certificates. You can think of one as more for management of Consul and the other for the operational aspect of the service mesh. So two separate certificates. I want to make sure. Daniele, you led it into a great transition point, by the way.
Yes, so I'll stop sharing and then pass the testimony to Eddie.
Yes. So speaking of auto config, Eddie, take it away.
Auto config. Yeah. Thank you, Daniele. That was great. So to continue the theme going along with this, the Consul and Vault better together stuff, I want to talk a little bit about auto config, the story around that in our security model. So I'm going to share my screen here and bring up our security model. And as Daniele was saying about the certificates, encryption is a big part of our security model here. Historically, and the way that I was doing it up until autoconfig was released, you would have to generate gossip keys. You would have to generate certificates for clients, different types of security settings to basically have those for each client. And then you may manually rotate them, or you may use some third-party thing like Puppet or Chef to actually send those out to your different clients to have them met. Enter autoconfig, and what autoconfig does is, instead of having to rotate these or do any manual operations to send these out, autoconfig will actually connect to the Consul server, which has these centralized settings. So clients will connect to a centralized server using a JSON web token, which we'll get into in a little bit. And what the servers will do is it'll establish a secure RPC channel to each of the clients. And those configuration settings will be automatically sent from the authorization servers, which are your Consul server clusters, down to each of the clients. And it'll do that as time goes on. So the value that offers is that rather than this manual rotation, if you connect using the autoconfig method, it drastically simplifies the management overhead and the security operations for your Consul cluster and your entire Consul environment. So what I'm going to do is I want to first show you the autoconfig learn guide here that we have recently put out. So what I'm going to do today is I'm going to go over kind of like a demo environment. The same demo environment with all of the detailed steps are inside, which Rosemary will share out later. She'll share the link here, but feel free to check it out yourself. It's Automate Consul Agent Security with AutoConfig. And what I'm going to do is talk about this environment a little bit and show you how the AutoConfig feature actually works. So in the demo environment I'm about to spin up, this is essentially the architecture. We have a Consul server cluster with 3 Consul servers. There's a Consul client that is going to connect and get its configuration from this. And then there's a separate Vault server. And so you'll see the integration between this here, where the Vault server will actually generate these JSON web tokens, these short-lived web tokens that are an OpenID industry standard. And it will give one of those web tokens to the Consul client configuration, which will then talk up here to the Consul server cluster, and the Consul server cluster will then send that configuration down. And you'll have a secure environment that meets our security model. So yep, that's essentially how it works. Now I'm going to go ahead and show you. I've already spun up the environment here using Docker Compose, which is what the tutorial does as well. And so you'll notice we have these 3 Consul servers we just talked about, the Vault server and the Consul client. And what I'm going to do is a little bit of a simplified. I've already gone in and created some of the Vault prerequisites for this demo here, but everything is outlined in the tutorial. So I just want to focus on the feature and share with you how this works right now. So what I'm going to do first is hop on over to the local Consul environment. And as you can see, these are the 3 server nodes here, but you'll notice that the client hasn't joined. So what we're going to do is we're going to figure out what's happening. I'm going to check the container logs here after I make this huge so everyone can see it. There we go. All right, so I'm checking the container logs to see why the Consul client is unable to join. And what you'll see some of these permission denied errors, error validating signature, the token has expired, or the token was rejected for some reason or another. And the reason for this is the communication channel is not going to be established unless that JWT has the correct authorization parameters. I'm going to show you a little bit more what that means right now. So what I'm going to do is I'm going to connect to the Vault server, and I'm going to generate a fresh JSON web token. So here's me hopping into the Vault server, and I'm going to log in with a sample username here that has permissions to generate these tokens. And again, the details for these tokens and how to create all the policies before you get to this step are in the tutorial. And also you have to type in the password correctly. Okay, there we go. So now what I'm going to do is with this account I just logged in with, I'm going to generate a token. And that token lives in Vault under the identity engine in Vault under OIDC token and a sample role called OIDC role-1. So what I'm doing is I'm reading that identity, and every time I read that identity in Vault with this username, it's going to generate a brand new token. And although I'm doing this manually in this exercise, there's points here for automation where you can either read via the API or read in the CLI to generate these tokens on the fly. Okay, so I just generated a new token here, and you can see this is the content of the JSON web token. And you'll also notice a few other attributes that are pretty cool. You'll see a client ID here, and you'll see a TTL. The client ID is essentially one of the attributes that's mapped inside the JSON web token that gives some validation and security around the JSON web token to make sure that it's only scoped to be used for particular clients in your environment, which are some built-in kind of security settings to make sure that not anything can join your environment. Another cool security parameter that JSON web tokens are known for is the TTL. This token that we just generated has a TTL of 12 hours, which is extremely conservative. This is a teaching lesson. In a production environment, you'd want to give it a TTL of maybe just 30 seconds or some very short value. So this token is only used to join the Consul cluster, and then it's done. There's no more need for it. Okay, so what I'm going to do now is I'm going to take this token that I just generated, and just as the tutorial highlights, I'm going to move that token over to this JWT file here, and I'm going to paste it and save it in here. This JWT token is mapped to the Consul client node. So essentially, basically, the Consul client node, when it starts up, is going to read that token file for the config. All right, so now that we have that new JSON web token generated and attached to the client config, I'm going to kill the Consul client here. That's me. There it is. Docker not found. Oops, I'm inside the Vault client. I'm going to leave the Vault client. There we go. Now I'm back to my command line. Okay. So I'm going to kill this for real. I'm really trying to kill it. It's not letting me. It's resilient. There we go. Okay, so what I've done there is I've killed the client and I've restarted the Consul client so it can read that configuration fresh. Okay, I'm going to go back to the UI now, and here you'll see the Consul client. So this is a totally secure data center. I'm going to show you some of those security attributes. Let's move this over. Okay, so some of these security attributes, like what happened here? Okay, cool. So now it's part of the cluster. Like that just looks like magic. But this is a secure cluster that has ACLs enabled. So it has that part of the security model enabled. It also has the gossip encryption feature enabled, encryption in there. And then it also has CA certs. So it has encryption at multiple layers, and it has the ACL engine and several security settings. And it was still able to join. The reason it was able to join is the client knew to go look on the client configuration, which I'll show you here. It's very simple. We have that intro token file where, so this is the auto config section. Let me go backwards a little bit. This section here shows that we have enabled the auto config engine, which uses that token file we just generated to look at the Consul server cluster for authorization. So when it starts up and that client configuration starts up, it goes to look at the server authorizers, and the server says, okay, hold on a second. I'm going to check some attributes here to make sure you're allowed to actually join the server cluster securely and establish this secure channel so I can send you these settings, these very sensitive settings. Some of those settings, the way that it checks is some of the settings here on the server side is it looks at these issuers and OIDC discovery URLs. What these mean right here is it's essentially going to look over at Vault. The console server is looking at Vault and is saying, hey, Vault endpoint, is this a valid JSON web token? Vault, since it generated that JSON web token in this case, looks at some attributes and goes, yes, this is a valid token. It was generated here at the issuer sites. It's good. So it comes back to Consul at that point and it looks at a few other attributes. And these attributes here, they can be some very complicated regex expressions that filter out to see exactly what's in the JSON web token. But in this case, it's looking at a few attributes to say, hey, is this the node name that we expect in the JSON web token? Is this the metadata that we expect in the JSON web token? And these are each various levels of validation for the JSON web token. So what the heck are these things in the JSON web token? What is it actually looking at? Well, I'm going to copy this JSON web token here, and I'm going to go to JWT.io, which has a debugger and decoding tool here. And I'm going to paste in this JSON web token that we just generated. And we can see that there's generally 3 parts of a JSON web token. There's the header, which have to do with also what Daniele was talking about, the algorithm and the token type. So here we can see we have, we're using the RS-256 algorithm. This is the encoding right here. This can be modified and changed inside Vault. You can use different types of encodings here. And so the JSON web token knows with this red part, it's kind of cool how it's broken down in different colors here. This is the correct encoding. The next section that it looks at is the payload. And this is what we were just looking at in the configuration on the server side here. These assertions and the audience and the issuer, we're looking inside the JSON web token here to see which attributes are actually part of this. So when this is being decoded, it's looking to make sure that the host name is the correct scope. It's part of the authorizer. It's also looking to make sure that the TTL is valid, that it hasn't actually expired yet. It's looking at the issuer. It's looking at all these attributes. And you can add a lot of attributes here, or you can do some really complicated kind of expressions to make sure that your scope is as reduced as possible for this JSON web token, which is the preferred kind of production practice for an environment. And so after this JSON web token is validated here, and it goes through all future settings, all gossip encryption, all tokens will automatically change over time. All you have to do is change it on the server side with autoconfig, so you get a lot of value there. You don't have to go to each client and change this gossip encryption thing. That autoconfig channel will automatically get the gossip settings. It will also get other settings, other security settings here will be pulled down, like verify server host name, and certificate information will be pulled down. So it's really great for scalable environments. It helps like with new console spin-ups, and it really simplifies like the overhead. So that is autoconfig in a nutshell. I highly encourage you to check out the Learn guide, where you'll see more of these details and how it's spun up in a way that's not so fast with me just kind of cramming it down into your brains. So do we have any questions for Vault and autoconfig and Consul?
I have a few. So the big, you go through this in the tutorial a little bit, but does this work just for Vault, or can I add something else? And what are the conditions for that something else, right? Does it have to generate JWTs? Like, what is it? What's the requirement for that to work?
Yeah, no, there's actually 3 methods that the Consul autoconfig authorizer supports. Vault is HashiCorp's tool, but there's a lot of tools out there that will generate these JSON web tokens or provide an OIDC endpoint. So one of those methods, like Vault, is the OIDC endpoint and OIDC method, and that can be used to verify these JSON web tokens. Another method that AutoConfig supports is the PIM encoding method. So you can actually put a public certificate that you generate on the authorizer, and it will use that public certificate to validate the JSON web tokens manually. And you can generate those public certificates using your own method. You can generate the JWTs using development tools like Second, which is linked in the tutorial, or there's other, kind of smaller grade tools that will generate those JWTs on the fly for your environment. Or there's also JWKS, which is another method similar to OIDC, where you have like a URL endpoint that will validate these services, and so you can have the Consul authorizer look at that to validate the JWTs.
Awesome. One of the things that I'm just curious about it. It's okay. We don't have an answer for it. But the Vault Identity Secrets Engine generates an expiration time for the JSON web token. What happens if that do you have a best practice or an idea behind what happens if you set that expiration time too low? Should you set it just enough for the client to register or the server to register? What are some patterns around that, and what should you consider as you're adjusting the expiration time for a job?
Yeah, absolutely. I'd say basically the Learn Guide itself goes over like how this works, and those, to emphasize those are not production level practices. This is to like teach the concept. But in a production environment, like rather than doing these manual reads, you would have, I think, some kind of something in your pipeline that would generate these tokens on the fly, like as you're about ready to spin up these Consul clients and connect. And then those JSON web tokens would have the shortest TTL possible. And you'd want to play with that to maybe be like, maybe 30 seconds, maybe a minute, something that gives it enough time to stay alive and for the validation process to happen. I think like a tiering up would be really good, starting something like 10 seconds and then working your way up to make sure it fits your pipeline. And that's just, as tight a security as possible, I think, is the better practice. Better to just, fail while you're developing this, at the beginning, and like miss some connections than to have too relaxed of policies in the future. Just, that's did that answer your question?
Awesome. Yeah, that's awesome. So it doesn't take like 30 minutes to register unless something is horribly wrong, right? Like if you're waiting 30 minutes for the client to register, that's probably an indicator that something isn't right. So it's safe to say maybe set it to 10 seconds and up to a minute if you adjust and you find out something is different.
Correct. Yeah, you got it.
Awesome. Okay. So we have a question. Will AutoConfig allow me to roll out Consul server cluster from Secret Zero, or is ACL Bootstrap still orthogonal to this?
Gotcha. For servers, since the servers host the authorization service, then I don't, and I can verify this and make sure later, but I believe today that servers still require bootstrapping and setup. Like it's not possible to use AutoConfig to set up the servers and have AutoConfig be that first secret for the servers, because the servers host that authorization service and perform that service for the Consul clients. Now, something interesting is this feature was actually born as HCP, our HashiCorp cloud platform was being created. So the servers in HCP use this protocol, I believe, to get stood up, and it uses it in that platform there. So I guess if you use HCP, it's part of the magic behind the scenes there for the self-managed platform. But in your own environment, yeah, you'd have to still bootstrap your servers.
That's good to know.
Just to like piggyback on that. So ideally, like the logic is on the server side, when you're configuring your server, either you're using HCP so that you rely on HashiCorp SREs to define your defaults, or you might want to spend some time. You wouldn't want something that spins up with some defaults, like having your router password admin. No, you want to make sure that that configuration is tuned for your specifics. And then what these options provide you is the possibility to spin up clients well, as fast as possible without thinking much on the configuration, because the configuration was already taught very well on the server time. So the server and the control plane should be set up with the maximum cure possible, and then you get all the speed on the client side.
Yeah, well put.
Awesome. This is something that was picked up, and I'm not sure if it is the case. So if you don't have an answer to it, that's okay. If any of you have the answer, I'm just curious. Is autoconfig using the JWT auth method in Consul? Or is it a whole separate, like it's a whole separate thing?
Sorry, I'm not really sure what the JWT auth method is.
So surprisingly, I didn't know this, and this was something I not recently, but learned a couple months ago. But Consul has auth methods, similar to almost like Vault auth methods, in that you can use these auth methods to authenticate to Consul. I know that Kubernetes uses it, for example, to, rather than use the ACL token mechanism. What this does is provide a layer of authentication so that you can retrieve the ACL token. I'll post a link in the chat for it, but I'm just curious if the auto config might be using this a little bit, or if it was a completely separate mechanism. I mean, I'm sure there was probably additional, I'll have to ask, but there was probably additional stuff added to it, but I wonder if it was using JWT auth method, at least for the JWT issuance.
That's a great question. I think Matt Keeler or maybe Hans Hasselberg would know a little bit more about that. Sounds like you are way more under the hood than I am there.
No, I was just curious because you mentioned it was JWT. I'm like, there's another thing that uses JWT in Consul. So anyway, it's a little known one. It was very funny. Someone was like, hey, can I authenticate to Consul not using ACL tokens? And so I was like digging into it, and so it exists as an auth method. So if you ever want to, go ahead, Daniele.
So on that thing, like, I'm not sure for autoconfig, but we have a tutorial that uses like the authorization method in Consul. But as far as I know, you already need to have everything configured. You cannot use that to configure your clients. So there are methods to authenticate in Consul, like in the UI or even in the CLI, without using a token. But I'm not sure that, I don't know if that it can be a substitute for autoconfig.
Okay, perfect. That is good to know. All right. I think we don't have any more questions that I can see coming into the chat. So in that case, I think I'm going to do wrap up. Thank you both to Daniele and Eddie, who have bravely demoed, and the demo worked. Thanks to Lynn and Karl for joining and doing some question support, especially since this is a pretty broad topic. If you have additional questions or you want to walk through this yourself, I did post some of the links to the tutorials in the chat. I'll also update the YouTube description with the links to the tutorials as well. And if you are interested in what Daniele walked through, there is a workshop at HashiConf. I also added that link to the chat. You're welcome to sign up. HashiConf Global is October, so you can learn about this and get more hands-on. We have a couple of office hours this week We have Nomad office hours as well as the CDK for Terraform. Check out our office hours page for new updates. And if you are interested in learning Consul and you want to learn it basically ground up, Cole, one of our developer advocates, wanted to learn Consul. So we've been learning / teaching and getting taught by some folks, including Karl, on Twitch. So we do that first and third Fridays. You're welcome to join us. Any other questions you have about Consul auto config, we may have Eddie on who will teach me about auto config in more depth. With that, I appreciate you joining us today. Thank you all for providing some really useful information, and we hope to see you at the next office hours.